Okay, we're doing the combined gas law lab. So the first thing I need you to write down is the temperature of the water of the gas in the flask. And since we are putting it in boiling water, the gas should be the same temperature. You can't assume that boiling water is 100, so I'm going to put my vernier probe in there and we're going to take a look. Hopefully it shows up.
Yeah, I can see it.
You never know if a screen shows up on a screen, you know?
Oh, right.
Yeah. So it's still going. This is not like a cooking show where they have the one that's already done, obviously.
That would take all the fun out of it.
It looks like it's going to stay right there. Nope, nope, 99.
0.1.
Mhm.
Oh. No? Uh-oh, you went black.
It's kind of,
Yep, ish, 99.2 maybe. I don't know,
Well,
it keeps going up and down. It went to 3 once.
yeah, it's pretty well sticking. Oh, well, I just kind of stirred it. Oh, yeah, maybe. Let's say it's 99.1 because it keeps
Okay.
going up.
All right.
Yeah, okay. So that is going to be your initial temperature of the gas. And then you have a bucket of water that you will be submerging your flask in, and so the gas in the flask should end up the same temperature. This is just plain tap water. I just ran it right out of this tap, just cold tap water. That looks pretty stable. 23, oh, of course not. 23.6, we'll call it 23.6. So that is your final temperature. You also need to know the atmospheric pressure for today, and since we're really close to Abbotsford and they actually use units that we use, I just went to Environment Canada, so weather.gc.ca if you ever want to use it, and I looked up Abbotsford because it's right across the border, and so atmospheric pressure for today is 102.2 kPAs. So write that down. You need to know that, 102.2 kPAs. Okay, so now what I'm going to do is take the hot gas that's in the flask and expose it to the cold water. So this is very similar to what you did with the pop can, right? Kind of remind you of that. The trick is that now I need to remove this without scalding myself. So I'm going to put my finger, which one should I do? Maybe, I don't know. Maybe
Scary,
this
you
one.
need a
I
mitten.
know, and the problem is I have to turn it upside down in the bucket. Okay, so I'm going to put my finger over the flask, and then I'm going to. Okay, so then I'm going to very quickly go over to the bucket, and I'm going to turn it upside down and submerge it all the way. So the gas in the flask is now cooling off rapidly, kind of like your pop can, but the glass flask is not going to squish like a pop can. So it's submerged, and it should be the same temperature as the water. And then I'm taking my finger off the hole, and you know what happened with your pop can. The volume of gas in the flask gets smaller, right? Because the temperature drops, Charles' law, it gets smaller. And so there's going to be some room in there that water will go in and replace. So I'm taking, you could even see it maybe. Okay, and then I need to, there's air pressure pushing down on this bucket, so I need to equalize the pressure. So what I'm doing is I'm looking at the level of water in the flask, and I'm making it the same as the level of water in the bucket. And of course, you can see that this is probably where you might get some experimental error because it's kind of hard to see. And just keep it steady. So I'm putting my finger over the hole. And so that's the shrinkage of the gas in the flask when it was exposed to the cold temperature. That's Charles' law, right? You change the temperature, you're going to change the volume. Okay, the Charles' law, change the temperature, change the volume. Some of you got a little confused about that. Charles' law doesn't change pressure. Okay, so that's the amount of space that the gas shrunk up. That's what was left. So I have to measure that. Turn this off. But you notice that I need, like, how am I going to figure out, like, what's left? Like, how much gas is in there? I have to figure out the total volume of the flask and then subtract. Okay? But you notice that there's a stopper in here. So I'm going to have to do another step after this. So basically, I'm just going to pour this in a graduated cylinder and see how much there is. And you can see that this could possibly be another place for your experimental error because there's obviously a little water in there. Impossible to get every last tidbit out. Okay, and then I'm going to look at so it looks like, I'll get rid of some bubbles here. Go bubbles. Oh, what's with the bubbles? There we go. Okay, so we've got 30, what would you say? Let's see, there's 35.
34 maybe?
Yeah, that looks pretty close. I would say 34. So 34 milliliters for the amount of gas, right, that, like, after the gas compressed. Okay, so that's the space your water took up. Then we have to measure the whole flask. So you know that this is at least 250 mils. Well, this is a 250 mil flask, so, or cylinder, so it's probably a bit small. I'm going to get a bigger one.
Well, there's one right back there by the sink. Oh, yeah.
That big one. I don't know what this big one is. This might be, we have a 500, that would be the best. Aha!
Perfect.
500, yeah. Perfect. Okay, so I'm just gonna dunk it in here and fill it up. Okay. And remember, the reason that I have to do this is because that stopper took up a little bit of space. Okay, let's see how much the total flask holds. Where's my... Okay, so this is 250. And where are we? Gosh, this is hard to see.
It is. It's a little more than a half.
Yeah,
halfway
so-
between.
Yeah, so that'd be 275. I think these are they're in fives, right?
I think so.
250.
You're not quite flat there, but I think you might be about 280,
250.
right? Because this is 300, so it looks like
Right.
it's just a little more
Then
than.
half, yeah.
Yeah.
So is it the 5 above? Or is it, it's hard to see. See, to me, okay, let's set it on.
Yeah. You almost need something dark in there.
Yeah, let me
to-
grab something. Okay.
Like a black something.
Yeah.
Yeah, there you go.
Here, a little
Okay.
creative ingenuity here. So, oh yeah, so there's 275, 280, 280, maybe 280, like 6. It's a
I was
little
going
bit,
to say,
because you're supposed to estimate past the last known line.
okay, so 275, 280, 285, a little more than 285, it looks like to me, right?
Yeah, so I would say 286.
Okay.
Okay. All right. And let me just double check, that's the total flask. I think those are the only measurements. So initial temperature, hot air was in the pan, final temperature of the water in the bucket, volume of water in the flask. That was, we took that. Total volume of the flask we just did, which gives you the volume of the hot gas. And then the other things you're doing are math. All right. Yay, okay, we're done.